We'll proceed in summation and integral calculus. Okay, so we are pursuing discussion in summation and integral calculus. Can we find solution through repeated summation? So that is the scenario that we are pursuing in quite detail. Can we solve a problem by dividing the problem into many parts? Can we solve a problem by dividing the problem into many parts? Solve the problem part by part and then add it. Okay, in that fashion, we have seen many scenarios where we can have the solution ready by dividing into many parts. We are pursuing a discussion where can we use a length vector. That is our invention. That is called length vector. Can we use length vector to have a summation? Then we can convert it to integral. Okay, to have a length vector and then to get a summation is very intricate issue. Very intricate issue. Okay, so in one scenario, we took example of a circle. Hop. Okay, so in one scenario, we took example of a circle. Okay, how to find area of a circle? How to find area of a circle is divide circle into n part. Okay, how to divide circle into n part is that this is x-axis, this is y-axis. Means this circle is centered at the origin. If I am saying this is x-axis, this is y-axis, this is x-axis, and this is y-axis. This is x-axis, this is y-axis. Now I have this radius. This is x-axis, and there is something called there is something called radius, and radius is moving 360 degrees. Radius is moving 360 degrees. Angle is 0, then then it makes n stopover. It makes n stopover. Okay, in that fashion, this is the first stopover, creating an area. This is second stopover, creating an area. This is third stopover. This is ith stopover. And then like that, we divide into n area. A circle is divided into n different areas. Okay, where each section has two radius. Each section has radius, two radius, and an arc. What is tradition now? What is area of the circle? Area of the circle is summation I equal to 1. Summation sign I equal to 1 to n. Area of the circle is summation I equal to 1 to n. Area capital A subscript I. Area of the ith section. What is area of the circle? If we see what is area of the circle, then summation I equal to 1 to n area of the ith section. Consider this is the first section. This is second section. This is the ith section. If this is the ith section, consider this is the ith section. Up. This is the ith section. If this is the ith section, then this is the arc. What we see, this is the arc, and this is the ith section. Okay, if it is like this, then what is area of the ith section? Summation I equal to 1 to n, area of the ith section. What is area of the ith section? If I am trying to find area of the ith section, then typically it will be considered as area of the ith section. Hop. Okay, area of the ith section. If this is the arc, that is passing like this as a circle. Area of the ith section, if I talk, consider this is the baseline. Then this arc, consider this arc. Arc is a straight line. Instead of arc line, it is a straight line. Considering this n tends to the way we have divided our circle into n different parts, where n tends to infinity, this angle is very small. Since this angle is very small, this arc will behave as a straight line. If it is a straight line, then it forms a right angle. Right angle. It can be seen. This is a right angle. If I leave this radius, it is a right angle. This is a base and this is the height. If I multiply base by height, it gives area of a rectangle that is formed like this. This triangle is half of the area of the rectangle. Okay, what is this length? What is length of this arc? This is r into delta theta I, considering I as section. So this arc is r delta theta I. This arc and a straight line are same if angle is very small. This is what I don't like. That's why I have invented length vector. This is what is something that is non-digestible to anyone. So anyway, this is arc and this is straight line, and both are same because this angle is very small. Now in that fashion, the area of this triangle is half of the rectangle formed by this. This is r and this is r into delta theta I. Half r into r delta theta I. Now summation I equal to 1 to n area of the ith section, that is 1 by 2 r into r area r into r delta theta I. Okay, now this I have to, if r is constant, like if I take this circle, then r is constant. R is not varying. I can take out 1 by 2 r square. Summation I equal to 1 to 1 delta theta I. Delta theta I, if I add all the delta theta, it will become 2 pi. More or less, it will become integration. This is what also I don't like. In book, this is typically written like this. Summation I equal to 1 to n sigma. Sigma sign means summation. Summation I equal to 1 to n. Summation I equal to 1 to n delta theta I is integration theta from 0 to 2 pi d theta. How? No one knows. This is what generally mentioned in the book. Okay, if I bring anything into integration has a nomenclature. Integration means there will be a limit sign, and there is limit for the independent variable. Independent variable is going from which location to which location. That is limit sign. Inside this limit sign, we have a dependent variable that is also called, I believe, integrand. Integrand. So limit and then integrand, that is the dependent variable, typically called function over x, and then multiplied by d of x. D of x is called differential part, or also called independent component. Independent component, differential part, integrand, dependent component, and independent component from where to where. It typically computes an area. If this is x-axis, and this is a function over x-axis. If this is x-axis, this axis is called function over x-axis. Fx x. There is a graph like this. And that graph is nothing but function over x. That is the height at every moment. If I say fx dx integration of x from one location to another location, this is the under this graph, whatever the area comes in from x one location to another location, that's it called integration. So if I say summation of I equal to 1 to n delta theta I, where if I add all the delta theta, it will become 2 pi. Hence, it is integration theta equal to 0 to 2 pi d theta. Completely wrong. That's why people digress from mathematics and especially calculus and vector, because they don't know what's going on. Okay, the idea is if I want to bring it, first why I want this summation to bring into calculus. I can sum it, right? All the delta theta I can sum it. Anyone say just it is 2 pi. Integration summation I equal to 1 to n, whatever n is, delta theta I is 2 pi, but we'll bring into calculus. When consider that n tends to infinity and this expression is complex, then calculating all the subsection where n tends to infinity is difficult. That's why we bring into integral calculus. Integral calculus must be in form of integration, function and dx, d over the independent component. Here, if I see this summation I equal to 1 to n, and then there is nothing, delta xi, there has to be a function and delta xi. That function is there, that is 1 into delta xi. Now we can rewrite as integration I equal to 1 to n function over x, where x is at xi, delta xi. Okay, now this is something like that. This is, consider this is x-axis, consider this is x-axis, and this is function over x-axis. Now I chop this from lower, consider lower limit is origin, and this is b, from 0 to b, or 2 pi, here it is 2 pi, 0 to 2 pi, I chop it into n part. Now there are sections here. Any ith section, first section, second section, ith section, n minus 1 section, n section, up till 0 to 2 pi, any ith section, if I see function over x, then this is the height of the function over x. If I multiply this with delta theta I, this is theta axis, this is theta x, and this is function over theta. This is delta theta I. If I multiply with this height, it will give the area of this strip. If I add all the strip, then it becomes this full area, that is nothing but f theta d theta from origin to 2 pi, same thing. So I have to add all the area, and then only it will become integral calculus. So now I have the height as 1, that is fixed, constant, and base is delta theta I. Summation I equal to 1 to n, 1 into delta theta I, or summation equal to I equal to 1 to n, function over theta at theta for the ith section, delta theta I. This is the function over theta, delta theta I is the area of one strip. If I add for all, it will give the area of the all section. It is full integration now. Now I can bring it to integral calculus. In limit theta 0 to 2 pi, 1, that is function over theta, 1 into d theta, that will come as 2 pi. Then it will become pi r square is the area. This is the traditional way of the calculating the summation to integration. What here the locha is? Locha, first of all, we considered arc as a straight line. That is the first locha we did. There can be another scenario where the radius is not constant. Consider that we are in the ith section. This is x-axis, and we are proceeding like this. First section, second section, third section, and then we are at the ith section. If I am at the ith section, this radius is the beginning of the ith section, and this radius is the end of the ith section. Why you are talking like that? Both are same. Both may not be same. If radius is function over theta, r equal to cos theta, there is a typical example. I believe 10-20 times I have repeated it. There is a circle. Circle can be formed by x square plus y square equal to a square. That is the formula of circle in Cartesian coordinate system. Circle can be found through the polar coordinate system also. R equal to cos theta. If someone draws, consider this is r, this is theta axis, and this is r axis. R equal to cos theta. When this, okay, this is r axis and this is theta axis. Make sense? Okay, this is not xy. This is theta, and this is r. I believe I did not mess up. I'm sorry. This is Cartesian coordinate system. This is x-axis and this is y-axis. I'm making a hybrid model as polar coordinate system. Now, in hybrid model polar coordinate system, radius starts from the 0 degree, and radius proceed like this. But r equal to cos theta. As we go along the theta, radius will start decreasing. So at the beginning, radius is maximum, that is cos theta. When theta is 90 degree, radius starts shrinking. When theta is 90 degree, radius is 0. Radius started from here and it went and it came here. When theta is after 90 degree, then radius will start increasing, r equal to cos theta. Now when theta is beyond 90 degree, radius start increasing. When theta is 180 degree, radius will be full blown, but it is negative now. So if radius is negative after 90 degree, when radius has started climbing up, it is negative. To make radius positive, I have to revert the direction. If radius direction is like this, in this direction, radius will be in other direction to have radius positive. In that fashion, radius will start moving like this. It will grow and move like this. Even though angle is growing in this area, radius is growing in this area to have positive. It makes a full circle. Someone can try. In that fashion, what is the area of the ith section? That is under question mark. Now, when ith section starts, at that moment, radius is r1. Consider this is x-axis. This is x-axis and this is the ith section. Then radius starts at this point. Consider that is r1. And then it moves delta theta I. After movement of delta theta I, radius shrinks. Because radius is a function over theta. Now, this is the original arc that we are talking. But now new arc is like this. Now tell me what is the area of this ith section. If I say if this is the arc, then and I consider arc as a straight line, then this straight line length is r1 into delta theta I. That is this line, not this line. This is a new arc. But still I consider the same. If you see in the book, then what is the area in repeated summation manner? If radius is function over theta, then the area is summation of all the sub area. Summation I equal to 1 to 1, I equal to 1 to n, area of the ith section. What is area of the ith section? That is 1 by 2, 1 by 2 into r2 into r1 delta theta I. That is this line. But we have to consider because this angle is very small. If angle is very small, then this line, the arc line, this may not be perpendicular and this line also. Not required. It will be perpendicular. The way the radius is shrinking to get perpendicular on this radius, the arc fall is it both r should be same. If r is shrinking, then this arc, that is the way arc is going on, this may not be perpendicular of this line, but still we consider perpendicular. What is length of this arc? That again we consider r1 into delta theta I. What is the area? 1 by 2 r1, 1 by 2 r2, this is r2, into r1 delta theta I. r1 and r2 are function over theta. So r1, r2, actually this r2 is, if this angle is theta and this angle is delta theta, then r2 is actually function over theta plus delta theta I, and this is function over theta. Net mathematically fundamental for the repeated summation. In calculation, the area is summation I equal to 1 to n, 1 by 2 r2 into r1 delta theta I. Means if I go beyond any, now still, what is r2? r2 is function over theta plus delta theta I. What is r1? Function over theta and then delta theta I. Then see delta theta is very small, I can close in r2. Now it becomes 1 by 2 function over theta into function over theta delta theta I. More or less it becomes summation I equal to 1 to n 1 by 2 function over theta whole square delta theta I. 1 by 2 I can keep outside. Summation I equal to 1 to n function over theta whole square delta theta I. Function over theta whole square is f theta. More or less I consider g theta. G is a function, that is g theta. G theta is f theta whole square. G theta delta theta I. This is a fit case again, the way we demonstrated earlier. G theta is the height and delta theta is the width. This is area of one subsection in theta and function over theta axis. This gives a full, if I add all subsection, it gives the full place integration. So it becomes theta 0 to 2 pi, 1 by 2 theta 0 to 2 pi g theta d theta. G theta is function over theta whole square, that is cos theta. R equal to cos theta is function over theta. Cos square theta d theta, integration theta 0 to 2 pi 1 by 2. Okay, someone can solve it. But here we have done too many imagination. That is the problem here. We have gone through too many imagination. When we talked about the ith area, how it works, it works. But there is no solid philosophy behind it. See, if radius were same, then only one assumption we made, that this is a curved line. Then since angle is very small, I turned it up into a straight line. Okay, but when radius is decreasing as move along the angle, then how this line and this line will be same? It is not falling on this at 90 degree also. Then how I can take as half of the rectangle it make on the right angle triangle? This is not a good way. That's why people, they do not take mathematics or something like that. Means Because they know that if mathematics go beyond a scene, then calculus will come. And so many assumptions are there in calculus. This is delta theta tends to zero, and then see how much we are doing. Is it a better way to do that? Okay, better way to do that is that. What is that? Better way to do that is that if I'm trying to, then how to find ith section area? Anyone would ask now. What is your way to calculate the ith section area? Okay, our way to calculate ith section area, if this is x-axis, this is first section, second section, and this is the ith section. Okay, if I see about the ith section area, then this line is the, consider this is a, this then ith section area where these two radius can be same. Two radius can be same. This is the arc line. If radius is varying, this is again a arc line, arc curve. If I demonstrate this arc curve, if I represent this arc curve as a vector, makes sense, and this line as a vector, makes sense, then cross product of two vector will give the area. Makes sense. This is pseudo code. In pseudo manner, I am saying like this. If I have a vector and if I have another vector, if I do cross product of these two vectors, it gives the underneath area. Typically, it is a parallelogram. Okay, if if this vector is not a, I cannot bend it. So the if the first vector which was a straight line, first vector means a straight line. So first vector means if it was a straight, instead of that there is a curve vector. This is what we are saying. And another vector is a straight line. Now if I do cross product of these two, then it will give area under it as per the mathematics. Cross product of two vector will give area underneath it. But this cannot be represented as a vector because this is a curve line. If I represent them, then it's possible. If I represent this curve line as a vector and there is another vector, if I do cross product of these two, it will give area underneath it. Makes sense? Okay, people will overstuck that it is not possible. Means how we can calculate, how we can represent it as a vector. Please watch our previous video. We have talked about it. How to represent a curved line as a vector. If I have a curved line, if I have any 2 points, okay, I do for 1 minute. So if this is a straight line and this is x-axis, then if this point is x1, y1 and this point is x2, y2, then what is the length of this line from x1, y1 to x2, y2? Represent it through a vector. Vector will be along the line. And then find the magnitude of the vector. That vector is called length vector. Here the vector will be x2 minus x1i plus y2 minus y1j. If this is origin and this, then x2i plus y2j. If this is x comma y, then xi plus yj. Xi plus yj is the vector that will go along the line. Okay, if I have a curved line, instead of a straight line, curved line, and this is the point x comma y and this is the origin, then vector representation of this curved line cannot be this connecting two points. This is a straight line. To have, we have to apply some brain. Okay, some mind we have to apply. Some effort is required. Now, in the straight line, every point, if I take y by x, it is constant, same. Whereas in a curved line, everywhere y by x, if I take, it is different. Means y by x is variable. So when we mention a vector, there vector must be mentioned as y by x because variable component must be there in the representation. Then only we represent it thoroughly. So if I have a vector representation of any line at xi plus yj, I have to take out x. It becomes I plus y by xj bracket close into x. This is representation of a curved line where the differentiation y by x where numerator is y that is function over x and then whole I plus y by xj whole is a function over x into x, function over x into x. So numerator and denominator function over x by x will change into differential calculus and multiplication into x, fx into x will change into integral calculus. So net arc vector or a curve vector can be represented as I plus dy by dxj bracket close into dx, or I plus delta y by delta xj bracket close into delta x. This is the curve line vector. Anyone can try. This is our invention. This is not there in any of the book. So we can try now. We are trying to find the area of the ith section. Now, if I have a ith section, this is one vector. Okay, and this is another vector. Just leave this vector. This is one vector, and this is the arc vector. This is arc line arc. Arc, if I take this arc as a vector and this as a vector, if I do cross product, we get area there. Purity, we get area there. What is arc vector? First of all, if I talk in polar coordinate system, the polar coordinate system has two variables, r and theta. If I try to demonstrate any point on the circle in polar coordinate system, this is again not mentioned in any of the book. If I want to demonstrate, if I want to place any point here on polar coordinate system in xy plane, not in r theta plane, in x axis, y axis. If I say my radius is rotating like this and angle theta, this is Cartesian coordinate system. Whereas if I take pure r theta plane, that this is theta axis and this is r axis, r theta will be a rectangle, not circle. This rectangle is mapped at a circle in xy plane, where theta will be like this and this is not r. Theta will be from x axis, theta will be in angular form and radius will be in this form. In that hybrid model, if any point P here, if I want to demonstrate point P, what is point P? Then someone will say this is r distance from the center, comma, theta. Theta is not a distance, both should be same, r comma theta. Then theta is represented through arc line, that is r into theta. How much angle we have moved, and what is the radius? R into theta is the r. So this point is r comma r theta, where r is constant and theta is variable. First r is r variable, comma r theta, where r is constant and theta is variable. Okay, what is this point then? R comma r theta. Theta is 0, r comma 0. What is this point when it is at 45 degree? Then r comma r pi by 4. R into pi by 4 means that is the r distance. Anyway, now if I say in vector form, then it will be r unit vector plus r theta unit vector. That is the vector form in polar coordinate system. Now, if we are trying to do cross product of two vectors, one vector is the arc vector. Now, what is arc vector? If I watch closely arc vector, any vector in polar coordinate system is r unit vector plus r theta unit vector. Like in Cartesian coordinate system, it is xi plus yj. Similarly, it is r unit vector. I and j are unit vector. Here it is r is in this direction. r unit vector plus r theta unit vector. Theta unit vector will be in the tangential direction along the arc or circumference or perimeter, whatever it is. Okay, now when we see that our theta is variable, when we talking about this arc, theta is variable, theta is moving. Okay, in that fashion, I have to take out theta from there, and it will become r by theta, r unit vector, plus r theta by theta unit vector. Theta I have taken out. If I bring into a length vector, means calculus, it will become dr by d theta. If radius is not variable, everywhere radius is same, then dr by d theta will be 0. Okay, let's keep radius as variable, like equation like r equal to cos theta. Dr by d theta, r unit vector, plus r d theta by d theta is 1. R theta unit vector. Okay, bracket close, d theta. Makes sense? This is the arc. This is the vector representation of this arc. Very precise, very mind-blowing. What is the vector representation of this r vector? Another vector, because we have to do cross product of these two to get the area, ith section area. Now it is again r unit vector plus r theta unit vector. I have to take out r. But mind it, if it is radius vector, then theta is not changing here. That is for sure. If I take this vector, then radius is changing. If theta is varying, If theta is varying, then radius is changing. That's why dr by d theta, I did not make it 0. But if I go along the radius, certainly theta is not changing. Okay, in that fashion, now it is r unit vector plus r theta unit vector. These are trillion-dollar explanations, not available anywhere. Now I have to take out r because r is independent variable here. It will become r by r unit vector plus r theta by r theta unit vector. In calculus, it will become dr by dr r unit vector plus r d theta by dr theta unit vector. Bracket close into dr. D theta by dr is 0 because theta is not varying with that r going in one direction. Theta is constant. It will become r unit vector dr. Make sense? Okay. R unit vector dr. Okay. Now what are these two vectors? What are this vector is dr by d theta r unit vector, or I can say dr by d theta r unit vector, or delta r by delta theta r unit vector, dr by d theta r unit vector plus r d theta by d theta theta unit vector, bracket close into delta theta I. This is delta theta. This is what we have said, or d theta. This vector is dr by dr r unit vector, or delta r by delta r unit vector plus 0, certainly, and then delta r or dr. Okay, now watch it closely. Now I have to take cross product of these two vectors. If someone watches it very closely, then what is d in the first expression? Let's say r is the first expression, then dr by dr r unit vector. Dr by dr r unit vector means how much r is changing, how much r will change if I make one unit change in the r. That will be 1 means r unit vector. R unit vector. Delta theta, just leave it right now. R unit vector. What is another vector? dr by d theta r unit vector plus r d theta by d theta theta unit vector into delta theta. Delta theta, leave it right now. Okay. Now we have these two vector cross product. First is r unit vector and second is dr by d theta. If I make one unit of change in angle, that is theta, how many unit of change I see in r, that is dr by d theta. Okay, more or less this vector is r unit vector plus r theta unit vector by delta theta by d theta. Actually this vector is like this into delta theta, that we will see later. First is actually r unit vector plus r theta unit vector by delta r. Means the vector what we are saying r unit vector plus r theta unit vector would change how much if I make one unit change in r, that is r unit vector plus r theta unit vector by delta r or dr. Another one is r unit vector plus r theta unit vector by delta theta. Means dr by d theta, how much radius is changing if I make one unit, or the top vector what we are seeing, how much the top vector would change if I make one unit of change in theta. Make sense? Now first and second, if I do cross product of these two, then I get more or less area. Cross product means area. I'll get area, but area first vector cross second vector divided by delta r into delta theta. This is what we are seeing. If I say this, then top two vector, first vector is this vector and second vector is this. If I take cross product of these two vectors and divide it by delta, this is what is happening. If I break the length vector, if I divide it by delta theta delta r, means if I make one unit of area change, delta theta into delta r correspond to area because two sides are there. If I divide by delta theta delta r, means the area that is made by cross product of this vector and this vector, how much this area changes if I make one unit of change in theta and r. If I multiply it by delta theta delta r, if this is the r1 and this is r2, then delta r is the change, and this is the angle from x-axis and this is the angle again from x-axis. If I subtract, then change in theta is delta theta I. This is This angle is delta theta I, whereas this R2 minus R1 minus R2 is delta Ri, is section. Now, I have seen that if I do cross product of two vectors, I'll repeat it again. Okay, what we are trying? We are taking cross product of two length vector. This length vector is dr by d theta r unit vector plus r d theta by d theta theta unit vector bracket close into d theta. This unit vector where theta is constant. Here it is dr by dr r unit vector bracket close dr. If I do cross product of these two, I'll get area between this vector and this. This much I know. Now let's solve it. Let's make it close introspection now. First is dr by dr, r unit vector. Okay, then leave the top part. Dissociate top and bottom. Top is now r. Actually, dr by dr r unit vector it is same as r unit vector plus r theta unit vector divided by delta r, where theta and r are unrelated. This is one section. Cross product of another one r unit vector plus r theta unit vector by delta theta. Okay, bracket close into delta theta delta r, that we leave it right now. It becomes like this. Now, if I make it closer, it will become r unit vector plus r theta unit vector, that is the first vector. Cross product with r unit vector plus r theta unit vector. Second vector, divide by delta theta delta r. First two vector, if I see this vector and this vector, then they give the area. First vector is this vector, second vector is this vector. It gives the area, area. Okay, area. I'm sorry. I'll repeat it again. I'll repeat it again. The first length vector is the cross product of two length vector. We are saying it gives the area. What is the first vector? This vector is length vector is dr by d theta r vector r unit vector plus r d theta by d theta theta unit vector bracket close d theta. The actual vector is r unit vector plus r theta unit vector. To get the length vector, I have to take out the independent component. So to get this, I take out theta as independent component. To get this, I took out r as independent component. Cross product of these length vector and this length vector will give the area there. This length vector, if I take out r in r unit vector plus r theta unit vector, if I take out r as independent component, it becomes now at the end, then I convert into integral calculus, it will become dr by dr r unit vector plus r d theta by dr theta unit vector bracket close into dr. Cross product dr by d theta unit vector plus dr d theta by d theta unit vector bracket close d theta. Okay, now we have come dr and d theta keep outside. Now we have come cross product of two sections. Now what are these sections? Dr by dr r unit vector plus d plus r d theta by dr theta unit vector. Okay, cross product with dr by d theta unit vector r unit vector plus r d theta by d theta unit vector. Now take the numerator and denominator separately. The numerator becomes d of r unit vector plus r theta unit vector. That will become dr and r d theta. And cross product with another one, that is d of r unit vector plus r theta unit vector. First is divided by dr and second is divided by d theta. Okay, more or less the top will become d of r plus, if I say r unit vector plus r theta unit vector as position vector, first will become d of position vector by dr. Cross product d of position vector by d theta. If I combine it, then it more or less it becomes the area dp by d theta dp by dr. If I say, then this is how much position vector is changing. If I see change in r, dp by dr how much position vector is changing if I see 1 unit change in R, dp by dr, 1 unit change in R, dp by d theta, how much position vector I see changing when there is a 1 unit of angle change in theta. Make sense? Okay, if I combine this definition together, how much position vector is changing in area fashion? dp by d theta r. This is what the combination is. dp by dr cross dp by d theta. If I combine, it becomes dp by d theta r. How much position vector is changing in area fashion if there is 1 unit of area change in delta theta and delta r? What is 1 unit of area change? 1 unit of area change means delta theta. If delta theta changes 1 unit, not delta theta I. Here delta theta I is changing and R2 minus R1 is delta R. If I say d of p, okay, if I see dp by d of p by d of theta r, how much position vector is changing in area fashion? What is area fashion? Area fashion is, consider there is a theta and r plane. This is theta r plane. In theta r plane there is a point called theta comma r. Theta comma r. Position vector is in Cartesian coordinate. This is x-axis, x-axis, y-axis. This is position vector p. I told that this is Cartesian coordinate system. If I take theta r coordinate system separately, then this is theta and this is r. There is a point called theta comma r. Okay, if theta comma r, this is the point. There is another point here. If this is the point, there is another point here. Okay, what this point is? This point is theta plus delta theta comma r plus delta r. If theta comma r move from, if a point that is theta comma r, it moves to another point that is theta plus delta theta, r plus delta r, what is the area it makes? It will make an area. If there is a 1 point here, if there is 1 point here and 1 point here, it makes an area. Okay, if this, I note down this area because area is found when theta change delta theta and r change delta r. What is the area? Similarly, there is a point P here. Because of this movement, P also changed from one point to another point. What is the area? If I divide this area by this area, I get how much this area is changing per unit change in this area. That is dp by d theta r. If there is 1 unit of area change in theta r, how many area unit I change in dp? What you want? I want area. I want area of this IS section. Then if you get area change, when there is 1 unit of area change in theta and r, that is change in area. Multiply with the delta theta and delta r, you get the area of this section. This is what actually it is. Then we have to rewrite it. What you have to rewrite is, we have to rewrite it dp by dr cross product dp by d theta. That is the area change in position vector when there is 1 unit of area change in theta and r. Okay, into delta theta r. What delta theta I, delta ri. If there is an area change when r changes from r1 to r2, then it is delta ri in the IS section and delta theta I. That will give the area of this section. This is completely perfect proof. This we derived from the length vector. Length vector is saying that area computed when we do cross product of this and this will be dp by dr, dp by dr, dp by dr cross product dp by d theta into d theta dr. This is what the actual length for, but we have to rewrite it now. dp by dr cross product dp by d theta. There d theta will become delta theta I. If it changes theta I, and dr will become delta ri. If r changes from r1 to r2, the difference is delta ri. Now what is the area of the IS section? Area of IS section is dp by dr, where theta is constant. Because first p, when we took this is the position vector of the radius, theta is constant. Make sure. Another one, this arc we take where theta is variable component. Here radius is variable component. Here theta is variable component, but r is also variable. So first is dp by dr. That was actually, if I don't go with dp by dr, what was there earlier? The dp by dr expression was actually, it was dr by dr, r unit vector, plus r d theta by dr, where d theta by dr was 0. So dr by dr is 1, r unit vector cross product. Another one was dr by d theta, r unit vector, plus r d theta by d theta 1, r theta unit vector. If I do these two cross product, what will come? R unit vector, R unit vector. This is for ith section I am calculating. R unit vector. So sorry, R unit vector cross product with R theta unit vector. R unit vector and theta unit vector cross product will give K unit vector, that is the perpendicular to this plane. K axis, x axis, y axis, and K axis, z axis. It will become as R K unit vector, this cross product, R K unit vector, and there it is R K unit vector, and there it is delta Ri, delta theta I. More or less, the repeated summation become like this. Summation of I equal to 1 to n, area of ith section. Area of ith section is R of the ith section, that is the beginning R. R of the ith section, that is a function over theta, whatever it is. R of the ith section, okay, delta Ri, delta theta I. This is the expression we are getting for the repeated summation. Makes sense? Okay. Now in that fashion, how it go along now? To go it along, we have to convert into integral calculus. Now whatever r we are saying, consider this is function over r and theta. We can rewrite it, summation I equal to 1 to n, function over r and theta, and delta function over r and theta, where r and theta correspond to the ith section. Delta ri, delta theta I. Consider there is an axis called r theta axis, not theta axis, not r axis, r theta axis. There is another axis called function over r theta axis. This is function over r theta axis, this is r theta axis. Okay, if there is a curve called in a function over r theta, if I say function over r theta dr theta, integration of r theta from one location to another location, it gives the integral. Whereas we have repeated summation I equal to 1 to n, function over r theta, delta theta I, delta ri, or delta theta, delta ri. Makes sense? This is, if I r theta axis, if I chop into n parts, then one section, ith section, if I take, this will be represented as delta theta r. Delta theta r into function over theta r will give the ith section area. If I add all the area, it will be f function over theta r d theta r integration lower limit to higher limit. This is a fit case to transform into integral calculus, where function over theta and r is r, and delta theta r, delta theta r will become d theta. Integration of theta r from begin to end, function over theta r, d theta r. Theta and r, I can break d theta r, I can break into d theta dr, considering theta and r are theoretically orthogonal to each other. F theta r is r. Integration of theta r from one location to another location. Now r is growing. If I talk about area, I'm not talking about circumference. If I talk about area, radius is growing from 0 to r. R is a function over theta, right? We have taken function over theta. R is not constant. If that is the case, then we'll come to our earlier example. This is x-axis, y-axis. If r equal to cos theta, this is if I say r is function over theta, then it will draw this circle where this is the center. Radius will grow with the angle and radius will start decreasing. Now I have taken any radius at this point. If I say r dr, now it is coming as integration r theta from lower to higher, r d theta dr. This is what is coming. Now if I see the now I want to set the limit. Theta will go 0 to 90 degree and then 90 degree, 0 to pi. Theta will move 0 to pi. What about radius? Radius is not constant. I cannot say radius is going 0 to a. Radius is variable. So radius will go 0 to function over theta. Radius radius will start from 0 and it will end because it is a function over theta, and that is cos theta right now in our case. So angle will go 0 to pi in this case, where the circle is made by equation r equal to cos theta. R equal to cos theta forms a circle. We have taken we are trying to compute area of a circle where r equal to cos theta. In that fashion, it comes as angle is 0 to pi, r is 0 to cos theta. Okay, r radius starts from 0 and it goes till cos theta. R dr, r square by 2, 1 by 2 I can keep outside, r square will become cos square theta. 0 to pi cos square theta. Makes sense? D theta. It came as the previous one only. If someone remember, 1 by 2 r square d theta we had made. 1 by 2 cos square theta d theta. That will come like that. What is integration of cos square theta d theta? That will be theta by 2 plus sine 2 theta by 4. Angle is 0 to pi. Then it will become, full will become 0 only. Only pi by 2 will remain. Pi by 2 into 1 by 2. Pi by 4 is the area of the circle, which has radius is half. If we draw a circle r equal to cos theta, then it will draw a circle, whose radius is half, and it will touch the origin like this. Then area is pi r square. Pi into 1 by 2. Pi by 4 will be the area. Okay, understood. Take the normal circle. I don't want that complex. Take the normal circle where this is the center and radius is not changing. This is the center and radius is not changing. Anyway, while doing the cross product, I believe I missed one item. Cross product was r unit vector cross product dr by d theta r unit vector plus r theta unit vector. R and r cross product will be 0. Only r and theta cross product will come, and that is the k. So it will come as rk only. Okay, dr by d theta will vanish. That is not required. Even though radius is changing with the theta. That's why luckily the first one we took as approximation that worked. Luckily. Okay, now consider that dr by d theta is 0. Radius is not changing with the radius is not. So original expression for the area is I equal to 1 to n dp by dr cross dp by d theta. Okay, dp by dr, in that theta is constant because radius is going like this. Theta will certainly constant. dp by d theta. There the p is changing with the theta, but r can be function of theta. So p is r unit vector plus r theta unit vector by d theta. dr by d theta may not be 0. Okay, but right now I'm taking at 0 because I'm talking about normal circle where radius is constant. In that fashion, if we cross product of r unit vector cross dr by d theta is 0, r theta unit vector, it will come as same r dr d theta, but r will be different now when we're doing. Angle will be 0 to 2 pi. Angle will be 0 to 2 pi and radius will be 0 to a because radius is not changing with the angle. So angle is 0 to 2 pi, radius is 0 to a, r d theta, r square by 2, a square by 2, 2 pi, pi r square, pi a square. Okay, this is something that we will do many work here. This is something that we can do repeated summation to integration, but repeated summation ith section mathematics we get through length vector, and that is accurate. Here we got one vector as radius vector, that was dr by dr, r unit vector. Dr by d theta is 0. R unit vector is the radius vector we got. R unit vector dr. Whereas arc vector we got as dr by d theta, r unit vector plus r d theta by d theta, theta unit vector, bracket close, d theta. If I do cross product of these two, I get the area of the ith section, where then we broke it into something like dp by dr cross dp by d theta and delta theta I, delta ri. This is what we broke. So that area of the air section will come and then sum it and then bring into integral calculus. We will make more examples where length vector make a crucial role in solving a problem. We do not mind supporting us. +91 is the India country code 9483160610 is a telephone number. +91 is the India country code 9483160610 is a telephone number.